the attendance first. Today is 23rd. Tausif is not there. Ajay is there? 01? No. Deepak Jadhav 03? No. Harsha, you're there? Present. Pradeep Das 05? Present. Rupam 06? Absent. 08? Absent. 09? Absent. 10? Absent. 11? Absent.
Sir, 10 is present.
Vinci? Ah, yeah. I think the others may come a little later. Okay, no problem. Later we'll see. Yeah.
So this is the lab experiments we are told that we should submit now.
Sorry?
So the lab experiments we are told no, to do on the office.
Yeah, on the word.
Yes, sir. You want us to submit?
Yeah, obviously.
So when, sir? You give us a time when to submit. Otherwise, simply people will take on because some people might have finished. I finished mine, so I'm like waiting when to submit.
Okay, if you have finished it, what you can do, see, I'll give you all the time. Uh, by 10th of next month. Is it okay? So I'm giving you all sufficient time.
Yeah.
Okay. So for everyone, 10th of October, you'll have to submit it. Okay. In that same word format which I've given it to you all. All right. So 10th of October.
Yeah.
So last time, I'll just share my screen. So last time we had done filters. So now we have to do transistor DC biasing. So let's do transistor DC biasing. So as I told you, same way what you got to do, how we did for filters, and then we collect on VLabs. Same way you have to do for transistor DC biasing. So let's type transistor DC biasing. Dash, we write VLabs. Click on enter. Okay, so let's see if VLabs is there for transistor DC biasing. If it's there, it's going to be very good. But if it's not there, then we'll have to check some other way. BJT characteristics theory, transistor DC biasing. This is the theory. I don't know if there is an experiment. Let's download this. So there is no experiment here in virtual labs. Okay, so we will just have to see some other means of getting it. So transistor DC biasing. So let's check this. You can see this, guys. You can see my screen.
Yes, sir.
Yes, sir.
Okay. So this is for transistor DC biasing. Okay, all the calculation, everything is given here only. I don't know if this much is required. Transistor DC biasing procedure. Okay. Resistor VB. This is cool. Calculate expected values, IPQ, and all. This much is not required actually. Connect voltage divider bias circuit. Transistor biasing. Okay, these are for all the circuits. I think VLabs, there's no other experiment where we can conduct it. So we'll have to go here only, but it is only the theory, guys. This is the full theory. Okay, you all can see this, guys?
Yes, sir.
Yes,
Okay.
sir.
Now, this experiment, no, it is basically your BJT characteristics, or known as your DC biasing or your transistor biasing. Okay, so what happens here? As I told you, as we know, a transistor is what? It is basically a switch. Okay, BJT, bipolar junction transistor. Transistor is basically a switch, like an on and off switch. Only that this is not a mechanical switch. It's a electronic switch. Okay, so this is basically a electronic switch. So if you can see this here, okay, you have your base, collector, and emitter. Okay, you have your base, collector, and emitter. This is a PNP one, and this is a NPN one, and this is a PNP. Okay, so now this we are basically studying more on NPN only. Okay, so we'll only go for the NPN one. Now, when you see the NPN one, you see the collector, you see the emitter, you see the arrow. So this is basically your current direction. Okay, so this is your current direction. This base, what you see here, is basically your switch. So if you give your base voltage here, your collector and emitter will short. If voltage is not given, your collector and emitter will not short. So it will not turn on. So you basically require your base. Okay, so you basically require your base to be turned on for the collector and emitter to be short. That means if you want conduction in this area. Okay, if you don't want the conduction and you want it off, then you don't provide any voltage at the base, and this will be an open circuit. Okay, for example, We'll take this common example, operation of a transistor. Okay, if you can see, you have a voltage here, VBB. Okay, this is your base voltage. This base voltage is going here. You can see here you have IC, and this is grounded. You can see this, guys.
Yes, sir.
Okay, so you have your VCC. Okay, now assume that there is a LED here. Okay, there's a small LED connected in series. So after this, it's connected to an LED, and then it is going here. So this is basically one circuit. Okay, now what happens is, say if VBB is given, this supply voltage is given, so this current will go in this base. So when supply voltage is given here, okay, this circuit conducts. That means this line here and this line here will short, and this will turn on your LED. If this base voltage is not given, this and this will not short. So if this and this are not shorting, your voltage is coming from here, so your current is going from here, entering the LED, but it is not going to the ground because it is opened here. Okay, but when a voltage is given here, that time both these things are shorting, and when they short, it conducts, and the LED basically glows. You all understood the working of this? This is a normal, simple switching technique of a BJT. Everyone clear with this? Sorry. You all can see, everything clearly, guys.
Yes, sir.
Okay, cool. Okay, anyways, I'll turn off the video. There's no point of looking at my face. So I'll turn off the video. Okay. Now we'll go on this. This is your characteristic graph. Okay. So when it basically turns on and turns off. So here you get your turn on for different values of IC. Okay. BJT characteristics. BJT characteristics you all had done first year, no?
No,
Yes,
sir.
sir.
No meaning. The diplomats, no, I guess. Others have done, no?
No, sir. We also we didn't do BJT and all.
BJT you all didn't do?
No, sir.
This thing, Ray, fixed bias, emitter bias, voltage divider bias.
Yes, sir. We had last time.
Yeah. So why all of saying you all didn't do, Harsha?
So I never came across BJT.
Oh,
Bipolar junction diode.
exactly. It's all done. Okay. But anyways, we'll just do a revision of that. Uh, so bipolar transistor. So we'll go here. Documents. So transistor DC biasing circuits. So now the various circuits are given here. Reduce the size of this. So this is your fixed bias transmitter circuit. So someone can tell me what is a fixed bias circuit? What do you mean to say by a fixed bias circuit? This was done in the first year, guys. What is a fixed bias circuit? Hello? You all are there?
Yes,
Yes,
sir.
sir.
मुझे लगा disconnect हो गया. What is a
नहीं
fixed
sir.
bias circuit? A
Where
fixed
base
bias
current
circuit.
is constant.
A fixed bias circuit is a circuit, okay, which has a resistor at the collector. Okay, this is your collector, which has a resistor at the collector and a resistor at the base. Rather than that, it has no resistors anywhere. This is basically known as a fixed bias circuit. So you have one resistor here and one resistor here. Actually, this resistor, what is here? Okay, this is also correct. No problem. It's derived from here. So you have one resistor here and one resistor here. This is known as a fixed bias circuit. Okay. So even you can use a fixed bias circuit to do your switching. Then we have emitter bias circuit for enhanced stability. So an emitter bias circuit, what we have, wait, this is voltage divider bias. Emitter bias is there. Yeah, emitter bias is not shown, but I'll show you what is an emitter bias. Emitter bias, you have a resistor here at the collector, you have a resistor at the base, but you have an additional resistor at the emitter. So here also you will have one resistor. So that gives you a better stability. So you have three resistors in total for a emitter bias. For a fixed bias, you only have two resistors. Emitter bias, you have another resistor which is here. It's not shown in this, but remember emitter bias is having a resistor at the emitter as well. Then the last circuit what we have is voltage divider bias circuit. In voltage divider bias circuit, you have totally four resistors. Okay, you have totally four resistors, wherein two resistors are connected to the base. Okay, one resistor is to the collector and one resistor is to the emitter. So it is basically two resistors, three resistors, and four resistors. So this is having a much better stability. Okay, it has much better stability circuit, and it is more refined, voltage divider bias circuit. So your switching here is even more refined and it has a higher stability input. So you are having here four resistors. So one resistor is basically at the collector, two are at the base. You can see here base is here. So you are having R3 and you are having R2, and one is at the emitter. So the working is the same. You give a voltage here. Basically, your collector and emitter will conduct, and it will provide the continuity or turn on or turn off the circuit depending upon the base value which is given here. So once the base value is given, it will turn on. When it's not given, it will be off. Only the thing is you will get a greater stability and much more better control. Rather than that, you all can just go through, read through all of this. Your full theory you can write from here, guys. Okay, the full theory you can write from here. I'll just show you all the link once again. Guys, you'll have to click on this. Everyone, you can hear me?
Yes, sir.
Okay, you have to click on this. Okay. Wait. Don't go for this one. Okay, this is the one. Okay, so you have to click on this link. First, you have to type transistor DC biasing VLabs, and then experiment number 2, BJT characteristics theory. Click on this. Okay. Array, what's happening? No, not VLabs. Okay, this is the link. Huh? So write the same thing, the theory and all that, the parts, the requirements. Okay. Here instead of electric test board, just write here breadboard. Okay. Just write here breadboard and all the things. So you have to copy all of this and put it in your Word. Okay. Guys, you are hearing?
Yes, sir.
Yes, sir.
Okay. So copy all of this and put it in your Word. You can start doing this as of now.
So the word is dead again. It's dying every few days. I don't know why.
Uh, Dying meaning what's happening?
So after few days, no, it gives me some error. I can show you right now on the video. I mean, on the call.
No. This is not a good place for it. What you are telling is basically the crack and all. Don't talk about it here. Okay. But we'll see about that. You can message me about that. Just remind me when I go home. I'll send it to you. You got what I'm trying to say, no?
Yes, sir.
Okay. But as far as the other thing goes, just copy paste it, and you'll start writing the experiment, guys. I think this experiment Pradeep is doing. Pradeep is where he's come today.
Yes, sir.
Okay, so Pradeep, you start doing the experiment. Okay, you all can combine also and do. I have no issue as long as the file is complete. I have no issue in that. Okay. See, I have already put an application stating for the this thing. I mean, I don't put an application. I've asked the HODs that we'll make it basically a soft copy. Okay, all are saying okay, but still they have to wait for the final confirmation from the principal. Okay, but I want basically soft copy. So if it's soft copy, it will be good for you. But if in case the principal changes or he says we will basically go for the return copy. Okay, the principal changes his next thing and says we'll go for return copy, then we'll have to do the return copy. But as of now, there's nothing told of return copy. So we can submit in PDF, and I feel PDF is better for you. So you can submit it to me in Word, and then I'll send you all the PDF copy wherein you can put in, fill up only those places where it's required, where the observation is done, and you can submit it to me then individually. Okay, is that clear?
Yes, sir.
Okay. So right now you all start writing this. Go ahead and start writing all of this. You all got this, right? Or you want me to send you a link? I'll send you the link on the this thing, the chat soon. Okay, that's the link. basically equal to guys.
Yes, sir.
Hello.
Yes, sir.
Yes, sir.
Hello, guys. See, first thing, I think you all already know what you all got to do. Okay, but since this all can do it at home as well. Okay, I don't want to waste time here because since you all have this subject, okay, you all have even cells. You all should know about your calculator as well. I think the practical you all got what you all have to do. Okay, you all understood how the BJT is working. But for the our subject says we require how to use the calculator effectively. Okay, so I'll be running the calculator videos. Just go through them. Okay, so I'll be pushing it. I want everyone being there. Okay, and checking. Okay, everyone.
Yes, sir.
I'll just take the attendance once again. If in case anyone was skipped, just let me know. Roll number one. Sorry. Tausif, absent. Ajay, absent. Jadav, 03. Jadav had come? No, no.
No, sir.
Harsha, present. Pradeep,
Present, sir.
Rupam, still absent.
Present, sir.
Rupam, present. Okay. Shreyas, 08. Absent. Shubham, 09. Shubham is also absent. Shubham is present. Okay. Vinci, present. Yatin, present. Shreyas came, 08. Rohidas, no, no. Guys, hello.
No, sir, he's not there.
Okay. Jadav is also absent. Okay. And Tausif also absent and Ajay absent. That is the final. Okay, I'll just present the screen.
Well, today we're going to talk about the FX991 ES Plus Natural VPAM series. The FX991 ES Plus has two modes of power. First is your solar panel, which is here, the small one, and it has even an internal battery. So if your internal battery fails, your solar panel will come into play. So basically this calculator comes in two sections. This is your first section and this is your second section. Now in the first section, this part here, this is basically like your normal calculator. And in the second section, which you can see here, this is where the scientific purpose of it comes into play. So you have your normal calculator, what you could do, your normal functions like plus, minus, multiplication, division, into, equal to. This will come in your first section and this will come into your second section. Your second section will be the specialized section for the scientific point of view. So this is your scientific calculator. Now coming back to the normal things. If you see the first section, it is just like your normal calculator. You have your 0 to 9 buttons. Okay, you have your multiplication, division, plus, minus, okay, decimal point, into 10 raised to the power of 9 or any value. You have your answer and you have equal to. Now, the basic function. Now say we have a problem which is 8 into 3 divided by 5 into 3. Now we already know the value. The value is 1.6. So I should get 1.6 when I substitute this value in my calculator. So substituting the value 8 into 3 divided by 5 into 3. Now this is what we would normally do because you can input all the terms and this, and it's quite a large display, so you can input how many values you want. So if I press equal to, I get 14.4, but the actual value is what? 1.6. Now why this comes? The reason to this is the calculator substitutes the terms which come first. That means when I input this value, the calculator will think it is 8 into 3, okay, then divide by 5, the whole term, into 3. So it takes first come, first serve. So actually this is the value, but the calculator will take the value as 8 into 3, which is first come, first serve. So it solved for this value, divide by 5, that means this whole term, divide by 5 into 3. So you get it as 8 into 3 divided by 5 into 3, which gives you the answer as 14.4. So now how can we write this whole term in just one expression to save time without this mistake coming into picture? So the most effective way would be to use your brackets. If you see in the second section, you have an open bracket and a closed bracket. So when I take the sum as 8 into 3 divided by 5 into 3, when I'm writing it in my calc, I have to specify open bracket 8 into 3 divided by open bracket 5 3 and close bracket. So I have to use my open and close here and I have to use my open and close here. So I'll open the bracket 8 into 3 close bracket divided by open bracket 5 into 3 and I get my value as 1.6. So this open bracket and close bracket plays a very crucial part in your substitution. So always remember, you can substitute it much effectively like this with the open and close bracket. You could even go for the conventional method, that is 8 into 3 and you get the value 24 divided by, then press AC again and 5 into 3 and then say 15. So 24 divided by 15. Then again 24 divided by 15 and you get 1.6. But this method is tedious. You could just get it in one step by using this methodology. The other aspect I want to talk to you about is the replay button. Now see, to come back to the previous, your Casio calculator saves nearly 15 previous values, 15 plus previous values depending upon the size. Now if I want to see my previous value, I can go on this joystick like button which has top, down, left, right. Okay, so I can go on top and you see your previous substitutions are all here. So say you forgot your substitution what you did previously, you can get your full substitution what you have done along with the answer. So previously I had used open bracket 8 into 3 close bracket divided by 5 into 3 which I get 1.6, which is basically a much easier method. So I can even use the replay button to go on to my previous values. Another thing, if I press my AC button, okay, it comes to the defined screen, but if I press replay, I still have my values. But now if I press the on button, you can see if I press the replay button to check my previous values, they will not be there. So whatever previous values are there, they will all be deleted. So whatever previous substitutions are there, you will not be able to view them once you press the on button. So always press your AC button. So when you press your AC button, you will retain your previous substitution values at least from 15 plus terms. But if you press your on button, all those previous values will be lost. So special care should be taken when you're pressing your on and AC button. So always use your AC button. Say you want to delete those terms or you don't want anybody to check those terms back again, then you can press your on button, all the previous values or substitutions will be deleted. Another thing of this calculator is, now say I type the value 8 into 3 divided by, as I told you, I have to use the brackets. So open bracket 5 into 3 close bracket equals to 1.6. Now say instead of 3 here I wanted 4. It's not needed that you have to press the AC button again and again type the terms. You could just go to the previous value which is here and say you want to change this 3 to 4. You can use the replay button. Now replay button, as I told you, the top and down is used to see the previous terms, but the side buttons, that is your left and right, can be used to change your values. So say I want to change this 3 to 4, I can just go here using my replay left and right. I can press delete and change it to 4 or 45 or whatever value. So I can just directly change the value here and press equal to, which makes it very simple. Now 8 into 4 divided by 5 into 3 is a simple value, but say it's a very complex equation which has multiple terms in it. So that's the time this comes in very handy. If you have written the whole term and you just want to change one value because only that one value is wrong, this replay button comes very handy. So this whole thing is known as your replay button, which is just like your joystick, which has left and right and which has up and down. So you can use this replay button and adjust your substitution values. So this replay button holds a very nice way of replacing your values. Now again we'll press AC. As you see the delete button, we even saw the function of it. So if I have 85 into 6 into 3, I can basically go to any value, press the delete button and change the value to whatever I want and press equal to. So the delete button comes very handy, but I have to use it in coordination with the replay button. Another function which you see in the first section, okay, would be the decimal point. Now if you have 2 into 5 divided by 3, so I can put my decimal point. Now you will see that there is into 10 raised to the power of x. This is for terms say I have a term 2 into 10 raised to the power of minus 3 divided by 5 into 2. Always remember, it is safe always to use your brackets. So if you have any multiplication term or division term, just use your brackets. It's not going to cost you much. Anyways, the calculator is quite advanced. It will give you your answers in the speed of light. So you don't have to worry. So say I have this term. I'll open my bracket. 2 into 10 raised to the power of minus 3. You can see this into 10 raised to the power of x. X will be the unknown variable which we have to enter. So into 10 is already given. So I can just directly press this. I'll input that value minus 3. Now I can use this minus 3, or I could use this minus 3 which is here in the second section. This is basically also correct. And it gives you a better understanding. You see the size of this minus and this minus, okay, the size of this minus is smaller, the size of this minus is bigger. This minus basically helps to tell you that the value here is in the superscript. So whenever you see this minus, it will directly give you a hint that it is a superscript value. But otherwise, you could even use this minus. It's not a big issue. Again, close bracket divided by open bracket 5 into 2 close bracket, and this is your value. So you could use this 10 raised to the power of minus 3 or minus 4 or minus 5 or 10 raised to the power of 6 for whatever calculations you require. So now say it is 2 into 10 raised to the power of 5 into 3 into 10 raised to the power of minus 7. So again, how to input it? I have bracket 2 into, I have bracket 2 into 10. I don't require the into sign because it already includes it. 5 open bracket into 3 into 10 raised to the power of, I can just directly use this, minus 7 close bracket, and I get the value as 0.06. So in this way, I can find out my values. I can even go back to the previous using the replay buttons as I told you. So my first equation, it is 2 into 10 raised to the power of minus 4. So you see, I don't lose my values, but if I press the on button, my values will be lost. Another important function of this is, now say I got this answer, I press equal to, I got the answer as 0.06. Now say if I want to substitute this value of 0.06, what I achieved last, into 102. So I want 0.06 into 102. So it's not required that I have to input 0.06 into 102. I can just use the last answer. This answer button is basically the last answer. If I press answer and I press equal to, the last answer which it had substituted comes, that is 0.06. So what I could do is I could just press answer, which would include this last substituted value, into 102. So I can get the value directly as 6.12. Let's recheck that in the manual way. 0.06 into 102. As you see, it is 6.12, which is the same answer what I got here. So whenever it takes the last substituted value. Now you see, if you press AC and you press answer and you press equal to, it will give you 6.12. It will not give you this value because it takes the last substituted value, which is 6.12. So this answer will always be the answer that you got in your last substitution. Okay, so this is the basic functions of your calculator, that is your section 1. Now you have a section 2. Now in your section 2 you have x raised to the power of 2, x raised to the power of 3 if you see your gold terms. Then you have x raised to the power of whichever value. Then you have log, you have in, you have 10 raised to the power of whichever value. Now, if you can notice, there is x raised to the power of 2 here, and there is x raised to the power of 3, which is in gold. So there are two buttons which is basically highlighted in gold. If you could see, it's highlighted in gold and it is highlighted in red. So you have these two things. So gold is represented as shift and red is represented as alpha. So you have shift and you have alpha. It is just like your normal keyboard. Say if you want to type the letter A in capital, you would use and A. Or I could even use caps lock, but I can use shift. So I have to press shift and A. So that will give you in capital. And if I want to just use in normal alphabets, small letter alphabets, I can just directly type A. So this shift and alpha basically act like those keys, which change the value of that button. So now now we have x square and we have here x cube, if you could see. So x basically represents any value. Say if I want 5 square, I want the value of 5 square. So what I have to do is I have to type 5 and then I have to press square, which is equals to 25. So this is how I got the value. So this x will represent the variable value I want to find out. So now say if I want to find out the value of 5 raised to the power of 2 or 5 square. So I have to just press 5 into this value, which will give me 25. Now say if I want to find out the value of 5 cube, it will be 5 shift. Now when you press the shift key, you notice your S comes. If you press your alpha, your A comes. So now I'll press the shift, which will basically target all the gold terms in my calculator. So now you see what? X into 3. So I press this. So it will be what? 5 cube or 5 raised to the power of 3, which is equals to 125. So this is how I can find out between square and cube. So if I can find out any value raised to the power of 2, and I could even find out any value raised to the power of 3 in this fashion. So this is for my square and this is for my cube. But now you will say, obviously, values are not restricted only to 5 square or 5 cube. Okay, they can even be values raised to whatever value, that is x. So for that we have another button here. So now if the term is 105 raised to the power of 18. So if it is 105 raised to the power of 18, I press 105 first. So 105 raised to the power of 18. So what will be the value of this? So 105 raised to the power of 18. So I press 105 and then I press this button right here. Okay. Now which says that 105 raised to the power of 18 and close the bracket. So this is 105. This arrow button here basically indicates raised to the power of 18. Or it indicates the superscript. So 105 raised to the power of 18 will give me 2.4, since it is 6, so 2.41 into 10 raised to the power of 36. So this is the value I have achieved. So it means 2.41 into 10 raised to the power of 36. Never forget to include this 10 raised to the power of 36. Okay, you will get your value into this term. So always remember to take this term into consideration as well. So always look out for your last term. If it comes 10 raised to the power of 36, then obviously you have to even include this, because this holds the major difference in your answer. So always remember to write it down. Now pressing AC again. The other thing what we have to see is the log. Now when you come in the studies or engineering studies point of view, we don't need a log table because the scientific calculator already provides us that option. Say you want to find out the value of log 18. So I just have to press So now say you want to find out the value of log 18. So if you want to find out the value of log 18, you just have to press the log value, press 18 and close the bracket. So you will get the value as 1.255, which is equals to 1.256. So this is basically the value of your log 18. Now if you notice how you press it, you press log, the open bracket directly comes up and you press 18. Now I'm not closing the bracket, I'm pressing equal to. I'll get the same value. There's no problem with this. But if now say the value was log 18 plus log 6. So I want to basically differentiate between these two terms. So for that reason, the bracket comes into play. So now if I have this value, I'll just go to my replay. I close the value. I close the bracket plus log 6 and close bracket. So it's always good to close your bracket. So if you have a bigger term, it can be substituted properly. So if this bracket wasn't there, okay, then you would get a different value, which is basically wrong. So as I told you, brackets play a key role. So always don't mind to put that extra bracket into account. It may just waste 2 seconds of your time, but it will give you a correct answer and you'll never go wrong. So always include your brackets. So this is how you can find out your log values as well. Now, say you have root 2. want to find out the value of root 2. So what I have to do, I have to press this root sign here, and I have to input the value. As you see, open bracket. So always close your bracket. So how much you get? 1.414. Now this is for root 2. Now say it is root 5, and again root 5. Whatever value it is, you can push in and close bracket. So this is how you can get your root values. Now this is for square root. Now say you want a cube root value. Then what you can do is press shift and aim for the gold key, which is here. I hope you can see it. Okay, so the gold key will include this cube root. So I press the cube root sign. So say cube root of 2 and close bracket. I can get my cube root value as well. So if I want cube root of 2, the value is 1.26. So this is another function. Now this is for square root and this is for cube root. But now say I want of any value here. So this could be any x value and any x value here as well. Because obviously in engineering we are not just restricted to square root and we are not restricted to cube root. We can even have 4 root or we can have 5 root. So say it is 5 root and the value is 25. Now how you will input this? Now if you check here, there is another function near x raised to the power of anything. You could see here you have a root sign which basically gives you any value, if you can see, which is basically highlighted in gold. So I press this shift button, I press this here, you can see it is x root and you have to input your value. So any root will do. So now say you have an example here, 5 root of 25. So I have to first input 5, shift, put that button. So this x will be the 5 value, which is my 5 root, and now 25 and close bracket. So I get how much? I get 1.904. So this is how I can get 5 root of 25. So what I have to do is just press this button. Now I will just cross check whether whatever I have done is correct. So what I could do is I could take the cube root value and put it in this same way. So if I have cube root of 2, I should get 1.26. So I'll use the same button here. So what I have, cube root of 2. So I'm pressing 3, shift this button here for any value. So now the 3 basically represents my cube root.
Das. Pradeep. Anybody there? Guys. No one?